Hi, good afternoon. Welcome to the Fab Lab. My name is Kelly O'Brien. I'm assistant professor of ceramics at the University of Dallas and the coordinator of the Fab Lab. This is the third year of a 3-year project, collaboration between NCECA and West Virginia University. We'd also like to thank Scut and Brackers Clay for their support of this Fab Lab. I'd like to welcome you to check out the show outside in the atrium on the pedestals that shows some of the collaborative work that happened as a result of the panelists working together to get ready for this presentation. Today, I'd like to introduce to you Shalaya Marsh and Liz New. Shalaya received her BFA from SUNY New Paltz in 1999 and an MFA from the University of Nebraska-Lincoln in 2016. She currently is a postgraduate teaching resident at West Virginia University Ceramics Production Facility. She has exhibited extensively, taught in the community, and participated in various residencies. And Liz New is an artist and designer based in New York. In 2012, she received her Master of Industrial Design at Pratt Institute in Brooklyn. Before Pratt, she attended the Oregon College of Art and Craft, received her BFA from Alfred University, and was an artist in residence and ceramic technician for the Pacific to Northwest College of Art in Portland, Oregon. Her work has been exhibited around the country, and she's taken part in shows in Clay Space, 1205, New York City's Nasty Women exhibition, Growth New York City Design, and the Morbid Anatomy Museum. Please welcome Shalaya and Liz.
Thank you all for coming. Liz and I are here to talk about our collaboration over the last several months. We were asked to participate in the Fab Lab to work together, to create work together for the exhibition outside, but also to discuss our working methods. And through the collaboration, we decided that we would focus on 3D printed tools. So I'm going to start by talking to you a little bit about our artistic collaboration and how we worked together to create specific tools for making in the studio. And then we'll present some work and examples of artists and educators who are making work and using digital tools in their classroom as a tool, really, to create and to customize what they're doing. And then,
And then I'm going to follow that up by talking specifically about how to use free software in your classrooms or in your personal process, and also like how to make a couple of simple projects that I have finished pieces here so people can kind of see how that works.
So we're going to show you a lot of examples, and we have examples here. So we'll leave some time for question and answer, and so that you can come up and touch the tools and ask us all kinds of questions about them. So when we first started talking about collaboration, we talked about a few different things. And in terms of 3D printed tools, a few of the options that we were running through were clay cutters and extruder dies. And we kind of narrowed in on utilizing a part of my process to create custom extruder dies for my work. So in my process, I take a lot of images from my sketchbook and translate those to laser cut resist and vinyl resist. I use a click and cut die cutter a lot to do vinyl resist. And so the process in terms of taking an image from my sketchbook and translating that into a digital design that could be outputted seemed to fit really well with the idea of creating custom extrusions and getting more dimensionality to those digital devices. So here's a couple of images of pictures from my sketchbook that were just taken, scanned, and put into Illustrator and cleaned up so that they could be outputted as SVG files. Liz and I kind of collaborated back and forth, and this was the beginning of us working digitally. I sent her digital Illustrator files, and she sent me back specs, and we kind of talked back and forth about what the specific requirements of the extruder dies were going to be.
And it was definitely an interesting process because a lot of the people I think who have talked over the last couple of days already knew each other and had kind of a relationship beforehand. But Shalaya and I were lucky enough to just get stuck together and then find out that like our aesthetics and our ideas about education and 3D printing and ceramics were like really close to one another. And so it's been really exciting to watch the whole thing kind of like blossom into like an awesome partnership.
We got really lucky with our pairing because
Yes.
it was very last minute, and we found that we worked really well together. And like Liz was saying, we have really similar philosophies about 3D printing and how you can use that as a tool in your studio practice or in your classroom. So here's an image of the some of the 3D printed extruder dies. These are for they were specifically designed for a Brent extruder, so has a round chamber. And the drawing is really the drawing that was used to make that extruder die. These can be, they're nice because they can be used for both hollow and solid extrusions. So when we were talking, we kind of went back and forth, and Liz designed this based on some specs I sent her.
Yep.
So the dies ended up being 100 millimeters around, and the bolt that was in there was 6 millimeters thick. So we kind of looked at where the drawings that I was sending her wouldn't work for the collaboration and would interact with the bolt for the extrusion. And we kind of modified things as we went along. And we ended up printing these about 6 millimeters thick. But in future versions, we kind of found out that you could go more like 3 to 4 millimeters, and I haven't had a problem with that in the studio. They seem to work just as good. I don't know about the longevity, because we've only been working on this for a few months, but they've held up good so far. So, and here's a kind of in-process shot of some of the parts. So you can see some finished pieces out in the exhibition in the vestibule that Kelly was talking about with the 3D or printed extruder dies used to extrude those parts. We also went along kind of thinking about how you could modify the tools to be more custom to your needs. And so this is a version of the tool that was designed so that it didn't have to use the metal part to hold the center piece of the hollow extrusion. It incorporates the bars that hold that extrusion. The pink one didn't work at all. When the clay got extruded through, there wasn't enough room for the clay to come back together, so it extruded out two different pieces, two halves, that I could cement back together. But
kind of ruins the point of using an extruder to have to slip and score your parts back together.
So a few modifications, lifting up the bar that held that piece together and adding in some fillets and some chamfers to allow the clay to kind of funnel back together really worked well. And so the finished part actually is printed up here. It works much better, and the clay actually goes together for that piece. So again, after kind of thinking about this and working on this, we were thinking and talking about all kinds of other tools that Liz is going to talk about a little bit later. And I wanted to pair these extrusions with some cut flat slabs. I like to play with shadows in my work, and so I was doing these drawings based off of the extrusions. I was taking these extrusions and laying them out and doing drawings of the shadows that they were making, and I wanted to create those out of clay. So in the same kind of way, took these sketches of these shadows from my sketchbook and then developed cutters, custom clay cutters that could be used to cut out a very specific shape out of clay. So this is the outside part that cuts the clay. And then also there's I call it a pusher downer.
Very technical term.
Totally techie. It just allows the clay to be pushed out of the cookie cutter without distorting. Because I'm using a porcelain, if the clay moves at all, it will warp and remember that in the kiln. So the pusher downer just allows me to pop that out. I dust everything with cornstarch. So with the cutters, it's really nice. Cutters and rollers and stamps, it's really nice to dust everything with cornstarch so that your parts don't stick. Because the PLA that we're printing will stick if you're doing cutters. So here's the parts together. And then here's just an example. You can see the finished piece and also multiples using those cutters to cut them out. I also will take the clay cutter because it has a really nice sharp edge and use it to do inlay or mishima. So I'll just press into the clay slab, creating a little divot that will be then filled with a different colored clay and scraped back to create those nice little lines of contrasting clay. Those pieces are outside, so go see them after this. And then during our research, we came across a lot of examples of people using 3D printed tools in the classroom. Some of the things that we've already talked about, but also some other things. And not only 3D printed things, but also using other technologies. So these are laser cut. So if you don't have a 3D printer, but I know printmaking departments often have laser cutters. If you have a laser cutter, access to a laser cutter, you can laser cut extruder dies fairly easily as well. These are just some extruder dies that were made for Francis Priest to make these little nuggets, beautiful ceramic nuggets. And this is a great example. This mold was made by Matt Kelleher at Alfred Ceramics. And so this picture encompasses this process really well. In the front, in green, you can see 3D printed mold parts. They're actually the cottle boards. So you strap all that together and you can just pour plaster in it. You do that 3 times and you end up with a mold in the round that you can slip cast. And the yellow cup is what was slip cast out of there. I have an example that we made at West Virginia University here that you can see down there in the orange. So after the presentation, feel free to come up and kind of see those pieces. One of the things I think is really great about this process where you're incorporating all of the keys and the cottle boards into the fabricated printed object is that you're saving yourself on a lot of work in that your mold is already parted. And you have perfect registration, and your keys are already made. You did that digitally in the software, and so then when you pour your plaster, you don't have to worry about any of those things. It really streamlines that process. And because this is a 3D printed piece of plastic, I can go and make 10 more of those molds if I want to. I can make them and then pour 10 cups at once, which is really great for streamlining your process and not having to part up that mold again. A lot of people are using 3D printed prototypes and making molds from them, but incorporating those cottle boards really helps to streamline and take full advantage of the benefits of that digital process. So this is Tyler Lotz. He taught a industrial processes class. He's doing a reductive process here, which you can see some great examples over here of that, where the foam is milled out again to make a plaster, an area for you to pour plaster in to make a positive mold. So some other fantastic tools out there. So we're going to talk about stamps for clay, but stamps for stamping, lettering is really fantastic as well. And also, I just love this idea that this artist has created his own business card roller that a piece of paper can go in there, and that business card can be embossed using that 3D printed roller. And in terms of the studio, we often think, like, how can we incorporate these tools? One of the things that I've been talking to my class about a lot is how can we solve problems that we have in the studio with the tools that we can make ourselves, model a tool to solve a problem. So here you can see Brooks Oliver has had problems with these vases that he was casting warping. And so he designed and printed this jig to dry his vases so that they would not warp. And this just solves a problem that you have in the studio. 3D printing really gives us that capacity to see a problem and design a tool to solve that problem, and then print it right there on demand. Another great one is integrating the designs that you're making directly into tools that already exist. So this burning tool was created at Oregon College of Art and Craft and in their Fab Lab and printed by Shapeways. And I love that this tool, it fits right on top of a Bic lighter, so that you just use the lighter to heat up the tool while you're doing your branding, I suppose. Yesterday, there was a presentation here by Jo Kamm, and we've been talking to Jo a lot about tools in the classroom and how you can use tools and how we can make tools accessible to people and how we can make 3D printing technology not really a scary thing. Because 3D modeling and 3D printing can be a little bit
It can be a little overwhelming if you're just getting started.
Intimidating if you don't know what you're doing. And our aim is really to make it really accessible and something that anyone can do. So these are cutters that Liz is going to talk a little bit more about how you can design these cutters and get them manufactured really easily. But I just love this idea that the custom cutter can be made. And these are tessellating forms, so they make these beautiful combinations of repeated forms. In a really simple way, this tool can make you make multiples very, very easily. So at WVU, one of the things that I had my students working on, and we have some great examples over here, was custom stamps for texture and inlay. So here are just a couple of examples of those. So they did straight drawings and then modeled their drawings and made stamps. And they loved it. We were all kind of a little tired of being in front of our computers the whole time. So one day I said, okay, we have all these stamps. Now we're going to get dirty and touch clay, when all we'd been doing was modeling in the computer. So these are examples of their stamps in action. And another great thing about the 3D printing and modeling is that this stamp here is this size, but once you've modeled something, you can make it in any size you want. So here you can see the 3 different sizes. So you have a design, and then you can scale that so that you have a lot of variety in terms of how you can use that tool. Here's a few examples of finished tiles, which there are some up here that you can see. And again, here's that Mishima technique that I was talking about, using a stamp or cutter to create a pattern that can then be inlaid with a second color of clay and wiped back. So this is a little tool, and I have a couple up here. This is a fantastic website called 3DP Rocks. They have a lithophane generator. I don't know if you're familiar with lithophanes, but they're really thin pieces of porcelain fired to a really high temperature, so they're translucent. And this lithophane generator, basically, you can bring any image in there, and it will create a height field that can be 3D printed. So here I just pulled this picture in here, and it made this STL file. And there's a couple of settings here, but none of this should be intimidating to you. Basically, you can set an image to be a positive or negative. A positive image will get you a beautiful positive lithophane. A negative image will not get you a nice lithophane, so keep it on positive. And the standard settings for this program of 3 millimeters in thickness and 4 vectors per pixel will give you a beautiful lithophane. This is an example of it being printed, the STL and the print. And then here's what the lithophane actually ends up looking like. So that's with the light behind the image. So you can see it's really a pretty direct translation. Jo did some amazing things yesterday that I thought were really kind of smart. Let's go back for just a second. So I'm going to point. Does my pointer work up there?
Can you see the pointer?
Oh, no pointer. Well, up there you can see the cylinder. solid cylinder. So Jo took an image and actually wrapped it around a solid cylinder to create texture rollers using the lithophane generator. It was a beautiful way of how some of these processes out here, they seem really complicated, but they can be so as simple as taking an image and dragging it into a lithophane generator and getting an STL exported that you can print.
All right, so now it's my turn. I am going to be talking about some more practical stuff as opposed to, like here are all our cool samples, but how do you use these softwares? How do you find them? What are they called? So I have here a list of the programs that I'm going to be talking about. They are all free. So there's Tileshop, CookieCaster, Tinkercad, and Onshape. And I will be talking more about each one as we move forward. This information should all be up online, and I think that they'll be streaming this stuff on YouTube. So if your pictures turn out fuzzy, the information should still be available. You guys are all welcome to contact me. I would be happy to send it to you as a PDF. All of this stuff should be available all the time. So don't worry if it doesn't work out. And I really, like, not everybody knows how to use a computer in the studio, and it can be really overwhelming to, like, try and learn how to make this stuff. So the first thing I'm going to talk about is making custom tessellated tiles. And the question is can you use an app? And if you can, then you can make these tile cutters. So you do not need like a deep understanding of how to use your computer to get started not only for yourself, but in your classroom, and get people involved in doing this kind of stuff. Hopefully this video will work. Here we go. I have a little video.
The video.
There we go. OK, sorry, I clicked too many times. So you can see that you can move the dots around, and it will automatically shift your pattern as you move the dots. So if you can move dots on a screen, then you can make a tessellated pattern. And once you have these tessellated patterns, then you can use that to very easily make tile cutters. So I know we've been talking about Jo a lot. I'm hoping that he's here somewhere so that he knows how awesome he is and how much we appreciate him. He developed this with Colin O'Keefe, and it is like really just a phenomenal and easy to use tool. So I'm going to give a couple of there's a couple of slides here that are kind of like screenshot slides that will kind of just show you like step by step with like little arrows, like this is how these things work, although I do think that video pretty clearly explains it. So you move the dots around. The dots, and one of the things that was hard to understand, I think, when I first got started with is on the far left-hand side, you'll see that there's a shape that you make with those dots, and where that shape actually showed up in the pattern, and like figuring out where that relationship was, I felt like took me a second. So you can see that the shape, that bowl shape, is the top of that cutter shape. And then that turns into the pattern. Now this I have on the table here. I made a couple of bad design decisions as opposed to like having anything not work, which is that I wasn't thinking that when you make things in ceramics and they are thin, they break. So the tiny little edges and the in-between of these parts, I had a ton of these made, and only 2 of them survived. They all cracked. So, think about like if you're going to be making something in clay. I just got so excited about using the thing. I was like, this is so cool, here's this thing. Yeah. Not my best move. So, like think about the materials that you're using and the shape that you want to make with those things. But that's really the most difficult thing about it. You name your file on the bottom, and then you export it. Once you have that, you can either use the SVG file, or you can do what I did, which is actually just take a screenshot of the patterned image. So you have your screenshot, and then you can go to this website called CookieCaster, which is a free website for making cookie cutters. And what you do when you get there is, log on. And on the bottom, there is I think the button says Trace. If you click on the Trace button, it will open a sub-menu that says Upload your photo. So I take my screenshot, I upload it directly into the system, and there it is. On the left-hand side, once you do that, there's a little button that says Magic Trace. And when you select that button, you can see in the upper right-hand corner, there's a little blue cookie cutter. That is your piece. So no 3D modeling, no understanding of what it takes to like move stuff around in space. If you are teaching small children and you just want to get them excited about having like stuff, or if you are just getting started with it, this is the most satisfying, like quickest way to have a finished model. There is a button on the screen that says download your model. So if you have access to 3D printers in your school or at the library, then you can download this file, take it to wherever you're doing your printing, get them to, if you have technicians or whoever it is, give them your file and do that. But there is also a button on the bottom right-hand side to access a company that I use a great deal, which is called Shapeways. They have a website where you can upload your files, and they will send you, you can just order things in like 50 different materials. And so you can use that as a resource if it's something that you don't have access to, if you are just in your studio and you're like, I don't have a 3D printer, I have no idea how to make this happen. They are great at providing these things for people. And then more cool samples from Joe's workshop. So he worked with students, I think, over the course of a week to make these pieces. And they turned out some really just phenomenal, like beautiful work. And I think it's just really inspiring to see. And to see how different each part is and how different each, like installation is, and how many variables are possible using a really simple tool. So next we're going to talk about making a texture roller. And the texture roller is only slightly more complicated than making the cutter, but you do have to, actually start to use a 3D modeling program. And the first thing that you need to know if you have never done any of this before is how important your mouse is. If you are using like an Apple computer or one of those mice, I don't know what one of them, you use one of the mice that has a single button, invest in the $10, go down to your Rite Aid, and buy whatever the cheapest version of a 3-button mouse is. Oop, and look at that. So
button
you
works really
will,
well.
for any 3D modeling program that you're going to use, you are going to need a 3-button mouse. And I cannot stress how important it is to have one. You can't do it with your pad. You can't do it with a 2-button mouse. You want to have the right tool, and it is definitely worth it. Oop, backwards. There we go. So this is what the buttons do. You have a button that makes selections. You can use the center roller to both press down and move an object around in one direction, or you can scroll to zoom in and out of your object in a 3-dimensional space. And then the right-hand button is used to rotate an object in the 3D workspace. So I know that sounds like a little bit random. So what I did is made a couple of small videos so that you can kind of see how this works. So this is the left mouse button, and you can see how it just moves the cube around on your work plane. And this is the center rolling button, so you can see that it moves the entire work plane without moving the box around. And then also the zoom button that like moves the pieces in and out. And then lastly, you have the right-hand button, which allows you, to rotate the piece around in space so that you can look at it in every angle. So it is not possible to do any of these things without a 3-button mouse. I can't stress it enough. So this is Tinkercad. So this is, and I think if you were here for the last presentation, they talked about using Tinkercad. It is a really lovely, simple interface. It is meant for teaching children how to use 3D design programs. And if you are an adult getting started, it is an even better system because you pick it up even quicker and you're like, oh my God, this is so cool, I can totally do this.
And the great thing about Tinkercad too is if you don't follow perfectly what Liz is doing, Tinkercad introduces you with a set of tutorials. It takes about like a half an hour, 40 minutes to go through the tutorials. But if you never used Tinkercad before, just go through the tutorials because it will show you many of the very, very important functions, and it'll remind you what Liz is going to tell you.
Yeah, and with anything that I'm talking about, there is a really amazing, like online source for tutorials for any of these programs is fantastic. So anything that didn't make sense when I said it, they have professionals recording videos all the time about how to do anything that you could possibly imagine. And once you feel like you can get in to the interface and move some parts around, then you'll start to realize like, oh, I don't know how to draw this kind of line, or I don't know how to make this kind of sketch. You don't have to feel like overwhelmed about it because you can just Google Tinkercad, whatever the shape you're looking for, or whatever you're trying to do, making a hole, and 10 videos will come up. So it's definitely something that is like really easy to start to learn. So here we have the interface. You sign on. You have to do the same thing you sign on to sign on to anything, which is give them your email address. And then you just say, hey, I want to make something. And when you do that, it will do this. So this is the only thing about Tinkercad that drives me crazy is they have a random word generator that automatically names your files. And it is,
really
I think this
names.
this one, they automatically named Mighty Trug, which means nothing, and it drives me nuts. So the first time I open any of the files in this program, the first thing I do is change the name. And you can do that the same way that you rename a file in like when you're looking something up in your computer, you just click on the text and you just change the name. So you don't have to do this. If you have no problems with their naming system, that's fine. It drives me batty. So I named this, I think, something obvious, like texture roller. Yep. And you can gives you like a small idea of what the interface looks like, but this will give you kind of like a quick rundown. On the far left-hand side, you'll see like a little box, and along with your mouse, you can use the box to change the direction that you're looking at something. And they're very obviously labeled to top, right, left, bottom, back. There are menus. All of the menus are up all the time, but some of them will be grayed out if you can't use them yet. So if you click on something and it's not working, it's because you're not at a point where it's something that will even function. And when you get there, the icons will actually change from gray to black, and it will let you access them. I think I only use one menu. I think for this demo I used the basic shapes menu, but there I think are 5 or 6 different menus. And there's all sorts of different shapes and just create dice and like pre-made things that you can kind of mess around with. And the thing to remember is that you can drag and drop any of these shapes. So you don't actually have to create something or do a drawing or model it or extrude anything. You're just like, oh, I need a cube. Here's a cube. So here you can see this is some kind of octagon, polygon they call it. OK, polygon. So you just drag it out of the menu and drop it onto your work plane, and there it is. And you can see that there's some things kind of around the object. When you click on it or you hover over it, these will come up. So there's a big black arrow on the top, and you can use this arrow, that arrow, to raise and lower your part. There are dots around the piece and on the top. So when you click on those dots, they will change color, and they'll allow you to change both the height and the width of any of your objects. And you can do that by clicking on those dots and dragging the dots. Or if you're making something that you want it to be a very specific size, like say the extruders that we're working on, you can actually tell it exactly what size you want it to be. So if you were going to make one of these extruder dies, you can find a shape that's the closest to the shape that you need. It's probably a cylinder. You tell it that you want the cylinder to be 6 millimeters tall, and you will have a 6 millimeter tall cylinder. Let's see. So now we're going to talk about the texture roller. And it's on the table over here if you want to see. I have some samples of having rolled it out. But in this case, I just used just a ball. So or a sphere, they call it a sphere. So here we go. So you drag the sphere from the menu onto your work plane, And then their shortcuts are very much like the shortcuts that you use on Google or anything like that. If you want to copy and paste, it's Control-C. So you already have kind of some of the knowledge that you need to use the software, but if not, all of the instructions for anything are all like up in the top. So you drag and drop it. And, whoop, sorry, I keep doing that. And then you copy and paste it. It'll just move it directly next to it. And then I copied and pasted it again, and it moved another one directly next to it. So you can see, in theory, you could make a texture roller just by continuing to copy and paste and make like a basic pattern of one shape. In this case, I wanted to kind of do something more complicated so I could talk to you guys about it. And so what I did was drag one of those dots around. And I didn't do anything special except for click it with my mouse and pull it to where I wanted. And now, like I have kind of a weird triangle sphere. It probably has a mathematical name. I don't know what it is. And then what you want to do is you select those parts and you group them together. And to do that, you can see in the top right-hand menu that there's an option for group. And when you hover over it, it will say group. So if you forget which one is which, you can always hover over your menu to select any of the tools that are available. And then what we're going to do is something that Jo taught me how to do, which is not just duplicate an object, but also duplicate all of the actions. So you can copy and paste, or you can duplicate this, which will give you a second part that looks exactly the same as your group. And then I use the little arrow to drag that group up. So you can see on the left-hand side, it kind of looks like maybe like a weird zygote. And that's because I've duplicated it and dragged it above. And then on the right-hand side of the slide, you can see from looking down from the top that each of the objects has, when you hover over it, it has a little back and forth arrow. And that arrow will allow you to rotate a part and in the same way as you can control the size of a part is the same way that you can control how far a part moves. If you want to eyeball it, that's awesome. If you need something to be like a specific 45-degree angle, you can type 45 into the little tiny boxes, and it will give you an exact angle. So then what you do, so I've raised this thing and I've rotated it. And if I have the object selected and I hit Control-D, which is duplicate, it will not just duplicate the object, but it will duplicate the action along with the object. So as I continued to hit Control-D, it lifted and turned and lifted and turned and lifted and turned those three little balls. So what you get is a tower of rotating patterns. So then what I wanted, because I didn't actually think about like measuring these things out and making sure it was perfect, is I want to align all of these parts. I think that a texture roller that's not perfectly aligned could also be super interesting. But again, I wanted to be able to talk to you guys about what was available within the software, and I felt like lining all the parts up to make a nice straight line is probably a good thing to know how to do. So again, on the top, there's a menu, and when you hover over that menu, there's a tool called Align. And what happens when you click on it, you select all of your parts together, and then you hit Align, and you will get these lines with the little black dots. And what they do is they show you how they're going to shift all of your parts together the same way as when you use a Word document and you tell your text, I want to align right, I want to align left, or I want to align center. So those dots are telling your objects the same thing that you're telling your text in a file. So if I click on the left-hand dot and that dot turns red, then it would line all of the parts up to the left. If I clicked on the right-hand dot, it would line them all the way to the right. In this case, I want everything to be centered, so I select the center dot. And it will shift everything center right, it will shift everything center left, and then what you're left with is a perfectly aligned centered part. So then the next thing is that you want to, usually for a texture roller, you want to have a hole in the center. Not just for being able to put a dowel or something in it, but also if you're printing in materials that aren't the FDM plastics, you are generally charged per cubic centimeter of material. So you want to be able to hollow out anything that you can hollow out because it'll control your costs a whole lot better. In this case, we're going to use the, we're going to drag and drop another shape out of the menu. And you can see there's like a big orange, what is it, cylinder? Big orange cylinder. And again, we're going to use the same tool that we just used to align all of our parts to align these two parts together. So you want everything to be perfectly centered. So you center it to the right, you center it to the left, and then you center the part in its entirety. And you can see from the top the little gray dots. It works the same way. And then what you do is on the top right, there is an option to either have a part be a solid or be a hole. And when you select hole, it will turn into like a grayed stripe. They also have, if you know you want a square or a cylinder to be a hole, there's a hole option. But you can make anything into a hole. You could, create like a die shape and put that shape into a different shape, and then, make all the parts around the outside of it into a hole, and it'll just delete those parts out of that object. So there's like a lot of like fun playing around you can do with this software that doesn't involve with just making a hole, but it's just removing one piece from another piece wherever they're touching. In this case, it turns gray. And then the thing to remember is a lot of the times you'll do this and you're like, why is it not a hole? This doesn't look like a hole. It looks like a gray cylinder inside of a blue thingy. Well, so what you have to do is group them together. So we use the same tool that we started with at the beginning to group all of the parts together. When you group all of these parts together, the hole actually becomes a hole. So you can see in the center there's like a little shadow, which I like. You can see that the hole it's projecting fake light through it, which is amazing. And then now that it's done, you can export your part. So on the top right, there's a little button called Export, and when you hit it, it will give you options for either OBJ or STL. Again, if you're working, if you have a lab at your school or you have people that you're working with, they will know what types of files that your printers will read. You can ask them. Most printers will read either of these, so it's not that huge of a deal. And if you do send your parts out, any website that you go to like order a part, they will tell you what types of files that you need to have. But really, STL files, almost always across the board, people will accept them for whatever you're doing. All right, so then the last thing is that we are going to talk about making custom glaze stencil. And this is where stuff gets a little bit hairy. So my background is in industrial design. When I went to school, I learned how to use very complicated engineering software. And the software I'm about to talk about is called Onshape. And it was designed by some of the same people. But it is cloud-based, which means you can do very complicated things from any computer. And if you do not want your parts, if you don't care whether or not the parts that you're designing are available to the public, the software is free. If you are an educator, or a student, which most of the people here are, then you can actually get a private account from them, I think either at a very large discount or maybe for free. You have to email them. But if you don't care who looks at your files, it's free for everyone. And as long as I am not doing professional work for other people, I use the free software. If it turns out that I have a lot of freelance work and I'm working for people who are putting things into production and they don't want things readily available to the public, then I think the membership for the year is something like $1,500, which in the grand scheme of softwares is not that expensive. But here you can see that there's a custom glaze stencil. And so we're going to start talking about Onshape. So it's like anything else. You create an account. You give them your email. You fill out the info. And on the far left-hand corner, you'll see a button that says Create. But also in that menu, you will see that there is a tutorial option. There are tutorials, again, far, far more detailed and in-depth than anything that I'm going to talk to you about today. The ability for me to get a long enough video is too much information to run in one of these slideshows. So what I have is a bunch of screenshots, and they definitely have some gaps on the inside. Also, again, Googling tutorials and Onshape is totally amazing. The community of people that is involved in this software, there is so much information, free and readily available to help solve whatever problems. And they also have a bulletin board where you can email their engineers. So you can go on and be like, hey, I'm working on this project. I can't figure out why this doesn't work. And you just post it. And then people will just email you back and be like, oh, hey, did you try this thing? Did you try that thing? I saw this great demo. It's over here. Here's the link. There is a lot of info. So this is what the Onshape workspace looks like. So it's a lot of different options in terms of like where you are looking at things. On the top, there's a lot of tools. We will be talking about a very limited number of them, and I am not going to go over all of them because we would be here all day. On the left-hand side, there's a menu, and what it does is it shows you every step that you've taken, and you can look at each step individually, and you can go back in and you can edit each step. So if you've drawn something and you decide that you want the circle to be smaller or the circle to be larger, you can go back into that and you can change that at any time, and it will affect all of the steps past your step. And if something that you've changed has caused something lower down in your instructions to fail, it will tell you and you will have to redo it. Let's see, on the far right-hand side, there is a box. It's just like the box in Tinkercad. It does exactly the same thing. You're working on something, you can't get deep into it or too far away from it. You're like, I don't know, I just want to see this from the front. You click the front button, and it will automatically bring it back to the whatever side of that box that you've chosen. And then also you have the option of drawing on different planes. Now, that seems super overwhelming, but the truth of the matter is that for a lot of what we're doing, you really only need one plane, and you can pick whichever plane makes you happy. We are not making engines. We are not designing buildings. If you are making tools, it totally doesn't matter which plane you pick. Pick one that makes you happy, and just get started. All right, so pick your plane. And then what I like to do is hide the ones that I am not using. So there's a little eyeball in the menu. When you click on it, you can make that eyeball open, or you can, it puts a little cross over it. I think maybe because closed eyeballs was maybe not clear enough. But it will make the other planes that you are not using disappear. And then what you have to do in this software, as opposed to dragging and dropping, what you're doing is you have a lot more control, and you are drawing the shapes that you want to extrude or that you want to be able to make. And so again, on the left-hand side, there is a button that says Sketch, and you will select the Sketch button to get started on anything. One of the things that people find the most frustrating is you're like, I don't know why this isn't working. Why won't it let me do any drawings? And it's because the computer is not as smart as you are. The computer does not know that you want to draw on the front plane until you tell it that you want to draw on the front plane. So the first thing it does is there's a little submenu that will pop up, and there's a blue box. Pardon me. And you have to tell it you're drawing on that plane. And once you do that, it will make all of the drawing tools available to you. So the first thing that we're going to do is, is make a sketch line, which is something that I use a lot, kind of if you're making something that becomes much more complicated, as a way to use as a reference point. And a construction line will allow you to draw a line that basically is like, oh, thank you so much, I'm sorry about that. That allows you to do a drawing that is just a reference point. You're not going to extrude it. You're not going to do anything with it. It's like, this is where the center of this thing is. No matter what I'm doing, I can see the center of this thing, and I'm not going to mess with it. So here you can see it's just a center line. And so it gives me a point of reference for where I am in this imaginary space. And you can align the center point by just hovering over it, and it will actually turn yellow, and it will tell you that you're drawing it straight. There are other tools that will allow you to straighten lines, but again, there is not enough time to go through everything. So the next thing that you will do is, if that is all we're doing, we are just going to click on the green checkbox, and that will finish that sketch. And there you have it. It's just, the line will turn from either blue or black to gray, and it will sit kind of below anything else that you're doing. You can kind of think of it like a layer cake. So you have the first thing, and then the second thing sits on top of that, and the next thing sits on top of that, and it all affects the other parts. So here on the left-hand side, you can see that it'll say Sketch in your menu, and then you can do a second. So the next thing we're going to do is do a second sketch of a circle. So and that circle is going to be the shape of the stencil. Again, you hit Sketch, you tell it what plane that you want to be on, and then you select the circle drawing tool. The circle will allow you to draw a circle. And it's like any other kind of drawing tool. Think of it like a compass almost, except for that it's just there. You can drag it all the way out or all the way back. And again, you can much like Tinkercad, you can control the size of any circle. So you can draw a small circle and then go to the measuring tool, which you can see in the upper right-hand corner. And then when you click on that circle, it will tell you the radius of it. And you can type in any radius you want. So it's easy to just kind of be like, all right, I'm starting with a circle. I need it to be, in this case, I think it's 203.2 millimeters. And you just hit go. You click the checkbox, and that gives you a finished drawing. So once you have a finished drawing, you can extrude from that drawing. And to do that, you use a different button. So the extrude button is, again, up on the upper left-hand side. And it's right next to the sketch button. So we're done doing drawings. Now we are going to make parts from those drawings. So on when you select the extrude button, the little box will come up. And the box asks you it'll give you a bunch of options. It asks you what you want to do. In this case, you want to make a new extrusion. There's nothing else that you're working on. And in my case, you want it to be very thin because it is a glaze stencil. So I think it's 0.7 millimeters, so it's less than 1 millimeter thick. And you can either type that measurement into the box where it asks you what you want the measurement to be, or again, very much like Tinkercad, there is an arrow. In this case, it's white instead of black. But you can drag that arrow back and forth until you feel like it's either thick or thin enough if you're just messing around with something. And it kind of gives you a lot of control as to how things look if you just want to just see. Oh, did I press the wrong button? Hello? Let's try this again. Forward. Thank you. So here is our disk, but there are no holes in it. So what I wanted to do was take a geometric pattern that I had and be able to apply that to this surface. To do that, I have to import a file. And there are different types of files that you need to have. Every software has different requirements. It just so happens that Onshape wants DXF or DWG files. The best way to get a DXF or DWG file is to use Illustrator if you have it. If you do not have access to Illustrator, there are actually free converters online. And I tried a bunch of them because I didn't want to tell you that they were available and then have them all be horrible and frustrating. And they are a little bit horrible and frustrating. And it's mostly because you cannot control the size. So in Illustrator, you can draw something and you can be like, this is 4 inches by 5 inches. And then when you export your DXF or your DWG, it is 4 inches by 5 inches. If you take a JPEG of some pattern that you like off the internet and you run it through one of these converters, you have no idea what size it's going to be when you open it up in your file. And it is not always the easiest to work with. So it's not impossible to do it with one of these free converters, but it is also something that you should prepare yourself to play around with it for a while before you find something that you feel like is working. I highly recommend, if you know anybody who has any type of access to Illustrator, there's probably any kind of architectural drawing program is going to have a DXF or DWG option available. That I would push for that because it's far, far easier than using the free options. If you mess around with this and you find a really good free option, please email me so that the next time I talk to people about this, I can be like, no, there is this awesome thing and here it is. But again, you create your file, you upload it the way that you would upload any file on the internet anywhere. You just select your file and it opens it up and it will show you that it has uploaded it into your system. And where are we? Yeah, so then, this is kind of, I forgot to put an arrow. So to the left of the menu opens arrow, you can see there's a sketch 4 box. And it says face of extrude is the face that I've chosen to draw on. So any flat surface along with your planes can be something that you can draw on. So instead of having to choose a plane to put this pattern on, I actually chose the surface of my disk. And I apologize for not having an arrow in there. That should have been a little bit more clear. And then what you do is you upload it. So there's again, in the top menu on the right-hand side, there's a little thing that says DXF. When you select it, the only thing that will come up is the file that you've uploaded. When you click on that file, it will open your pattern into your file. And all of these dots are drawings that you can use to select either separately or together and either extrude or subtract from whatever it is that you want to, that's in your file. But again, so always use the checkbox if things aren't working and you can't figure out why it won't go to the next step. It's usually, for me, it's because I have forgotten to check the green button. And that is the thing that will allow you to continue to move on. So here you are. You can see on the left-hand side, we have all of these layers of drawings and extrusions and drawings and extrusions. And now what we're going to do is make another extrusion. We are going to extrude all of the triangles into the disk. And we're going to do that just by selecting, again, extrude has an option where instead of being new this time, you want to remove. So instead of having like a whole or a solid option like we did in Tinkercad, here you can make it a solid. So I could send all of these tubes through this thing and make some kind of crazy texture press. Or I can say, no, I really want these to be holes. And it will extrude holes in whatever shape that you've drawn your sketch in. And so here you can see from the side, again, you have the same triangle, the same little arrow that you had in Tinkercad that will allow you to drag the depth of these holes however deep however deep you want them to be. And you can just see that I'm dragging the holes through the disk. And you can see here, there it is. And there are samples of that and the plate that I made with a glaze stencil on the table. So you can come up and take a look at what 0.7 millimeters of material looks like. It is not vinyl. It's actually 3D printed acrylic. So again, I don't have a machine of my own. I'm not an educator. I'm an industrial designer and an artist. And so I use a company called Shapeways, and I order my parts from them. And one of the nice things about it is that you can upload the parts and you don't have any requirement to buy them. So you create an account with them, you upload whatever your file is, and then they offer a ton of different materials that you can order parts in. And it gives you the price of what all of those parts are. Some of the parts that I made one of the white nylon piece that's up here. I ordered just to kind of see what the difference was going to be between having a nylon part and having a FDM plastic part. And the only difference was the nylon part was astronomically expensive.
Really expensive.
It was like $95 to print the part, and the FDM part works as well, if not better, and it cost like $7 to $10 to print it. So, like cost is not, spending a lot of money on something does not necessarily make it better. But it is nice to know that there are options available if you don't have a printer and you're not somewhere where you feel like printers are readily available. If you're using this in a classroom or for a workshop, you should know that there is several days lag time, because if you order something, then they have to make it and then they ship it to you. But it's a little bit like Christmas. I love getting a box with a tool in it and being like, yay, it's done. Yeah, and then when you're finished, you export it. So it's the same kind of idea. There's a menu on the bottom that says Part Studio. When you click on it, there's an export option. And the export options are a little bit more heavy duty because people use this software to make really complicated, crazy things like engines, which obviously we are not doing. So a lot of these things kind of don't make that much difference to us. But you want to name your part. You want to pick the type of file. Again, if you're working with shop tech, your tech will know what kinds of files that you need to have in order for them to work with their slicing software. Ask them. And you can export it as whatever that is. You want your file to be binary and not text. Text files are not going to work. Units, I design everything in millimeters, partially because I work in manufacturing and that is how things happen. but also because it is really easy. It does not matter whether or not you work in millimeters or in inches. It does matter if you remember what the units you exported are. I don't know if your technicians will need to know, but certainly when I order parts online, one of the things that they ask you is, did you make this in inches or did you make this in millimeters? And if you tell them the wrong thing, it will upload the part the wrong size. So keep an eye on that one. Resolution medium I have found to be totally acceptable. And yeah, and then you just want to download it, so that's the option you pick. You hit OK, and then you have your part. So the other thing is, I don't, like, again, there wasn't enough time to kind of demo everything that I got excited about making when we started working together, but I did bring samples of those things. So I made ribs out of the shape of my face. So that's a silhouette. And I did that the same way that I did the spray stencil. So I pulled a picture into Illustrator of myself, my husband, take a picture of me from the side. I traced the front of my face. I measured one of the ribs that I like, that I use all the time. I made it that size. I drew a little square on the back of it, and then I opened it up in Onshape as a DXF file, and I extruded it and then made the point skinny. And that was that was the whole thing. And I think this part cost me, I want to say $35 to order. I ordered it in 2 different types of plastics because I wanted to know which plastic was going to work better. And interestingly enough, there's acrylic and there's nylon. The white is nylon, and the kind of cleary yellow one is acrylic. And the nylon one actually worked far better because it has a little bit of a tooth to it, whereas the acrylic one it's very sharp and was actually tearing into the clay as I was trying to work on the pots. So it was nice to kind of see the difference in what the different materials would do. And then again, I designed a texture roller of these little tiny skulls because I basically put skulls on everything. And again, the different materials made a big difference. They cost about the same amount of money to order. But in this case, the acrylic part worked a lot better than the nylon part. And again, for the same reasons, the acrylic part was much sharper. And the nylon part has kind of a slightly hairy surface, which you're welcome to come up afterwards and handle the tools. We have some little slabs and things so you can mess around with stuff. And I was surprised at how much of a difference it made just between the 2 rollers. And yeah, so also I have made all of the tools that I talked about available online for you guys to download. So if you feel like you'd like to try printing any of this stuff at home and you don't want to model it, these are the files. Again, these will be available online, if you take a picture and it didn't come out, because these are really long strands of numbers to have to type in. And hopefully I'll be able to get this up on my website so that you guys can download it for free and just go through everything and ask me questions if you want to, maybe sometime later. And then finally, just thank you to everybody. I mean, it's been really fantastic to be part of the Fab Lab. Everybody at NCECA has been amazing. We definitely couldn't have done this without Jo, so thank you, Jo, again. We'll just keep thanking you. Yeah, and we would love to have you come up and take a look at all the stuff we're doing and ask us questions.
Does anybody have questions now?
Questions? Is there a mic or anything? There's not. Okay. How thick was the stencil? It's less than 1 millimeter, so it's 0.7 millimeters is the stencil. Yeah, no problem. That was an easy one.
Did you have to print the handle as well? Yes.
Did I have to print the handle as well? Do you mean for the roller? Yeah. It's one part. I actually printed it as one part. So I designed the roller the bead is on it. Both the nylon and the acrylic print in what's called laser sintering instead of, so the printers that you see a lot with the clay and the printers that are in a lot of people's studios are the ones that kind of work like a giant glue gun, right? You put the plastic in, it melts as the robot arm moves around and you get a final thing. The machines that these are made of actually laser the layers of material on a bed. So there's a layer of material. It's like a micron level of material, and then laser, and then it moves down, and then micron of material, and then laser, and it moves down, and so on and so forth. And so you can actually make parts that are interlocking, and they won't glue together. So the acrylic they do on a wax. They use a wax that they melt away, and the nylon is all powder. Yeah, no problem. I'm sorry? The last slide.
I put it up, but they have to put it back up.
Oh, what's that?
Oh, she wants
that
one.
I'm sorry. The green one.
Oh.
Yeah, so that's both of our emails. You're welcome to email both of us. And my email or my website is also elizabethnewdesign.com. So I don't have any PDFs or anything up right now, but I will do my best to get it up on the website so that people can download it.
Yeah.
When you did the extruder dies, were you 3D printing them with an FDM machine, or were they also made by Shapeways?
Both, actually.
So
Yes.
My question would be, is the ones that are FDM,
Yeah.
can they still also be the thinner 3 millimeters?
Oh,
Yeah,
yeah.
so,
And you can see them up here. They're great. Oh,
So they wanted to know about the.
Shall I give me a second? Let me repeat the question.
Oh, yeah.
She
I
came
was
here.
gonna.
So the question was about the extruder dies and whether or not they were ordered from Shapeways or whether or not they were FDM printed in the studio, and also about the thickness of those dies. And the answer is both, and now Shalai is going to talk through it.
Yeah, so originally they were the thicker material, but then sliced them down a little bit so that they would print a little quicker, and both worked just fine in this material. The one that we did that was really, really expensive in the nylon
it was stupid.
is a little bit thicker. And again, we should have redesigned this before we printed it in the nylon. We were just kind of going quickly to go through the iterations and kind of see how they worked.
Well, and not only that, but the other tools that I had made, it actually made a difference to have it in one material instead of another material. And so we had made these dies out of the FDM, and I was like, well, I wonder if it would be better or worse than the nylon, and like, let's see what that does.
So we tried it out to see, but this was definitely not worth the material. You can just print this on your 3D printer. These are PLA, and I did 100% infill on them when they were printed, and I think actually you could either lower the infill so that you weren't printing them at 100% or slim them down, because again, that 6 millimeters was more than I felt was necessary. I haven't gone lower than 4 millimeters yet, but I probably will, just in terms of the printing, and see how slim we can get them. The 4 worked just fine. I didn't have any issues. Again, I didn't use it for months. We've only been doing this for a couple of months, so I haven't been using the die for that long. But if you come up here, I mean, they're pretty sturdy. They're pretty strong, and I didn't really have any issues. We did have a few issues, like in a form like this, where this could be used as a solid extrusion or a hollow extrusion. It's got the part for the center. I had a few problems with these thinner areas extruding out a solid. So it was mostly because there was so much pressure at the center of this that the clay didn't want to be forced through that skinny little part. It was completely fine when the center part was put in, because this was distributing that pressure evenly across the form. And even some of these, like this one, is a second iteration because it just wouldn't print with the center part in. It wouldn't extrude that outer part, so it had to be expanded. But that really was just the pressure from trying to do the solid and all that clay wanting to go in the middle instead of out to those little itty bitty parts.
So it's not tapered like my North Star, the dies on that are tapered?
No, but you can make tapered parts. I mean,
Yeah.
that's the beautiful thing, is you measure the interior of like whatever, if you have a die and you know what those measurements are, you can use the measurement of the outside of your current die, and you can make tapered parts in any of these programs.
So we're talking about putting draft on it?
Yeah, yeah.
The outside part, it's supposed to narrow.
Yeah, and we didn't do that. I actually had some issues, like I tried to put a draft on one of the ones that was, had issues with the extrusion at the end, but the drawings were really complicated, and so it was cranky. with me. And I don't have a lot of skills. So Liz did all of the initial designs for those parts, and then some of the modifications I was trying to do. And I don't have nearly the level of skill with the program that she does.
They look amazing. And the finished parts are beautiful, so
yeah.
I feel like it was totally a success.
Yeah. So do you all want to come up and touch some of these tools and continue to ask us questions up here?
Yeah, because we're here for another half an hour.